In this video, we'll learn about the remainder theorem and the factor theorem. This concept falls under Algebra in Pure Maths 3. So subscribe and let's get into it. So the remainder theorem states that if a function f of x is divided by x minus a, then the remainder is f of a. So if f of x is divided by x minus a, then the remainder is f of a. We'll look at this in more detail when we look at a past paper example. Then the factor theorem states that if x minus a is a factor of f of x, then f of a is equal to 0. So this is the factor theorem and this is the remainder theorem. There's really nothing much to this concept, so let's just walk through these ideas with a past paper question. So we have the example, the polynomial ax cubed plus 5x squared minus 4x plus b, where a and b are constants, is denoted by p of x. It is given that x plus 2 is a factor of p of x, and when px is divided by x plus 1, the remainder is 2. Find the values of a and b. So we're told that x plus 2 is a factor of p of x. So according to the factor theorem, it means that p of negative 2 is equal to 0, because the factor theorem states that if x minus a is a factor of f of x, then f of a is equal to 0. In this case, we have x plus 2, so that means that, and our function is p of x, so that means p of negative 2 is equal to 0. Now we're also given that when p of x is divided by x plus 1, the remainder is 2. So this is where we apply the remainder theorem. So this becomes p of negative 1 is equal to 2. The remainder theorem states that if the function p of x is divided by x minus a, then p of a is equal to the remainder. So in this case our a is a negative 1 and then our remainder is 2. So now we can simply substitute and we end up with two equations in terms of a and b, and we solve those two equations simultaneously and then we can evaluate a and b. So let's do that. Let's substitute x with negative 2. So that becomes a times negative 2 cubed plus 5 times negative 2 squared minus 4 times negative 2 plus b is equal to 0. So this becomes negative 8a plus 20 plus 8 plus b is equal to 0. So negative 8a plus 28 plus b is equal to 0. So now let's substitute when x is negative 1. So that's a times negative 1 cubed plus 5 times negative 1 squared minus 4 times negative 1 plus b, and this is equal to 2. So that's negative a plus 5 plus 4 plus b is equal to 2. So that's negative a plus 9 plus b is equal to 2. And so that's negative a plus b is equal to 2 minus 9, which is negative 7. Let's make b the subject of the formula. So that's b is equal to a minus 7. And we can substitute it into this equation over here. So that becomes negative 8a plus 28 plus b, which is a minus 7. And this is equal to 0. So negative 8a plus a is negative 7a plus 28 minus 7, that's plus 21 equals 0. So 7a is equal to 21, which means a is equal to 3. and we can come back to this equation to evaluate b. So b is equal to 3 minus 7, and b is equal to -4, and this would be our final answer. So just to recap, the factor theorem states that if a polynomial f of x is divided by x minus a, then f of a is equal to 0. Then the remainder theorem states that if a polynomial is divided by x minus a, then the remainder is f of a. So that's all for today's video. If you enjoyed it, please like and subscribe for more videos like this. Thank you for watching. Bye bye.